So I'm going to take a moment or two to talk about how to name halogenated alkanes. Now, as you'll see, this follows simply the same naming procedures that we've talked about before. So halogenated alkane is our first alkane derivative. So by alkane derivative, I mean it's got something other than just hydrogen and carbon. So alkanes are just purely hydrogen and carbon, single bond, single bond, single bond all the way through. An alkane derivative has something else on it. And we're going to see a lot of alkane derivatives this quarter. But we're going to start with just talking about halogenated alkanes. So there could be one, there could be more halogens, they could be different halogens. Remember again, halogens are fluorine, chlorine, bromine, iodine, group 7 of the periodic table. Halogenated cycloalkane, simply put, is just a cycloalkane derivative with one or more halogen atoms present. Fairly straightforward. The naming is going to go exactly as before, except for now we just sometimes have a halogen substituent as opposed to an alkyl substituent. So, simply put, halogen atoms are treated as substituents on the carbon chain, and their names are fluoro, chloro, bromo, and iodine for fluorine, chlorine, bromine, and iodines, respectively. So, if we had something like this, we had C. So we start, as always, by naming our parent chain. So our parent chain has 4 carbons in it. So our parent chain name is going to be butane. That's going to remain unchanged. We're not going to change the parent chain name yet. This chlorine atom, or this chlorine atom, is just considered a substituent on the chain. So we have to start numbering. As always, we're going to number closest to a substituent. So we'll start from the right-hand side. 1, 2, 3, 4. So there's a chlorine atom on carbon number 2. So we have 2-chlorobutane. Pretty straightforward. Now instead, let's say we have both a halogen and an alkyl substituent. So I've got So we're going to find our longest chain, which is pretty clearly, it goes up to here, and we could branch any of the 3 ways. They're all the same. So there we go. We're going to start numbering from the right-hand side because it's closest to a substituent. 1, 2, 3, 4, 5, 6. So this gives us our parent chain name of hexane. And our substituents now, which my 1 is making it look an awful lot like. We have a bond there, which we don't. So this is carbon 1. So we have 3 substituents. We have 2 methyl groups. We have our bromine group. So our substituent names are going to be, there we go, got it back, good. So our substituent names are going to be dimethyl and bromo. The numbers preceding dimethyl will be 2, 2, because both the methyl groups are on carbon number 2. Bromo will have a number of 4. So 4 bromo, 2, 2 dimethyl. We have to figure out the order. The order is always based on alphabetical order. We consider methyl groups, not methyl groups, all alkyl groups, and halogen substituents all to be of equal weight. So we're not preferring one over the other, either in order or in numbering. So all that does, we just go right back to alphabetical. And as always, the di doesn't count as part of the numbering, or as part of the alphabetization. So we start with 4 bromo, 2 2,2-dimethyl. And I sort of ran over my hexane there. But so it's 4-bromo-2,2-dimethyl-hexane. Again, we're just naming all the parts, and in the case of halogens, we're just naming the halogens. Again, fluoro, chloro, bromo, iodo. So I want you to try maybe naming a couple of these. Let's try naming each of these in turn. So you can go ahead, you can pause it and take a moment to name them before I start. So when we name this top one, we're going to find our longest chain. Our longest chain, 1, 2, 3. We could go 4, 5, 6, or maybe go 4, 4, 5, 6. They're both 6 carbon chains, but again, we always want to pick the parent chain that has the most substituents and is the least complicated. So we don't want this big weird thing, a substituent with 2 bromines on it. That gets a little weird. So what we'll do is we'll number from, again, the right-hand side, 1, 2, 3, 4, 5, 6, because it was closest to all of our substituents. So our parent chain is going to be hexane, and we have bromine groups, and we have an ethyl group. So this becomes 2,2-dibromo, 3-ethyl hexane. So 2,2-dibromo, indicating we have 2 bromine atoms on each one is on the second carbon of the chain. 3-ethyl, we have an ethyl group on carbon 3 of a 6-carbon chain. Okay, let's look at the second one. All right, finding the longest chain may be a little tricky, but it looks like this is probably part of the longest chain. So 1, 2, 3, 4, 5, 6. Now we can either go 7 or 7. Now again, they're not going to be both the same because both these branches aren't the same. Again, we want the one with the least complicated substituents, the most substituents. So our longest chain is 7 carbons. So heptane, and then what we have is we have 2 different halogen groups. So we have a fluoro and a chloro, and we have 2 methyls. So what we're going to have is we'll have, and we should start numbering from the left-hand side. Now, you can't, it's important to note, you cannot have an alkyl substituent on carbon number 1 in a acyclic hydrocarbon, or in an alkane, because if it was attached to carbon number 1, the chain would just be longer. So, but you can have a halogen on carbon number 1. So we have 2 methyl groups. So this is going to be 2,3-dimethyl. We will have 1 fluoro, and we have 3 chloro. So we have to look at what order it's going to be. Chloro is going to come first because of the C, then fluoro because of the F, and finally methyl because of the M. So remember, di again doesn't count. So 3 chloro, 1 fluoro, can I get it in there? 2, I just have to erase, I guess. 2, 3, dimethyl heptane. Okay, well, I hope that clears everything up. I hope that makes everything clear, and I'll see you next time.